What is x1 equal to? X1 is equal to, this is the 0 input response we are finding. Then UN is 0, we don't have inputs at all. So x1 is equal to A times x0. And what is x2 equal to? A times x1, and which is equal to A square times x0. What is x3 equal to? A times x2, which is equal to A times A square x0, which is A cube x0. So in general, x of n will be equal to A to the power of n x0. So what is my equivalent of this? A to the power of n. So this is the so-called transition matrix. So this moves the initial condition to the value, or that how the effect of this at the value t sampling point equal to n. As we call it transition matrix. So here the transition matrix is nothing but A to the power of n. Yes or no? Simple. So what is zero state response? If you have a driven system, that is containing both zero state as well as input, then what do you get? X1 is equal to AX0 plus BU0 and X2 is equal to and this is equal to A into AX0 plus BU0 plus BU1 which is equal to A square x0 plus ABU0 plus BU1 . Like this we go on, you get xn equal to response due to both input and the an x0 plus sigma k is equal to You see here what I am getting here. For 2 I am getting to the power of 1, right? So it should be to the power of 1a. So n minus so the output will depend upon the initial condition and the input, and this equation is something similar to the second part. Okay. In fact, one can show that this is nothing but your original convolution. So this is the response, or putting other way around, if this is my x0, if the UNs are given, we will go to this x of n by this trajectory defined by this equation. Once I know this transition, I can find out the response output yn as equal to Cxn plus dun as a simple algebraic relationship. I can take Z transform on both sides. Remember what I am trying to do is to find out this response from the inversion of the Z transform. In the case of continuous function, remember we had AI minus Si minus A inverse don't remember? We wrote there x of x dot t so this was equal to S of x0 xs minus xx0 remember in the continuous domain, which was equal to Si minus A into xs is equal to Sx0 plus Bus. So xs gave as equal to Si minus A inverse into minus Sx0 plus Bus. this something like this equivalent I am trying to find here. This is a continuous domain. So I can get that by taking a Z transform on both sides. And the equation comes out to be xz is equal to z into z minus you take the Laplace transform of this on this side, Laplace transform on this, Z transform on this side, S transform on this side, then you will simplify this, you will get x given by this. Similar relation as what we had in the continuous domain, Zi minus A inverse. And A is a matrix, so I can invert it. And the inverse transform of the inverse Z transform of this will be your x of n, which we wrote here. So the sample data people use this methodology to analyze the system, sometimes using the state space approach. You can see that, you can show that this is same as what we have got here by writing expression for this. This expression is got 1 by and if you expand this in terms of binomial theorem, you will end up into same kind of a result.